If you're a data professional and have been struggling to learn Python, this video is for you. In under 20 minutes, I'll show you how to conduct an exploratory analysis using just 20 lines of code. Python is an extremely powerful tool used for everything from data science to web development. But a lot of people avoid it because it feels really complicated. But what if I told you you don't need to be a computer scientist or a professional coder to build job-ready Python skills? Thanks to built-in functions and libraries, you can do some pretty advanced stuff without having to memorize or write complex code. In this video, I'll demystify the world of Python and Pandas and show you that learning this stuff probably isn't as complicated as you might think. Now imagine that you've just been hired as an analytics consultant for a local restaurant. The owners are concerned about rising costs and need your help. Your task is to explore customer order records and use Python to identify the most popular dishes, busiest order times, and identify opportunities to streamline operations. Along the way, you'll learn how to read in and profile data from flat files, join data across tables, apply filtering, sorting, and aggregation methods, and use charts and graphs to visualize your data. Let's go ahead and give it a shot. In order to complete our quick analysis, we need data stored in two different CSV files, orders.csv and menuitems.csv. We're going to need to combine the data in both of these files in order to answer the following questions. Which items drive the most and least revenue, and which time periods have the highest and lowest revenue? Let's take a quick look at these tables before diving into the analysis in Python. Our first table, orders.csv, is a transactional table containing information about what was ordered and when it was ordered. And each row in this table represents a single item ordered. So if we look at this first row here, this represents one item ordered at our restaurant. It was ordered at 11:38 a.m. on January 1st, 2023. We have a unique identifier for every item ordered. This is the primary key of this table, but we also have an order ID. This represents all of the items a customer purchased with a single transaction. So for example, our first row here, there was one item ordered because there's only one row associated with order ID 1. And which item was ordered was item 109. We're going to need to join to the menuitems.csv table using this item ID. If we take a look at our second group of rows, this is order ID 2. There were 5 items ordered. So for example, somebody could have ordered burgers, fries, a drink, etc. on order ID 2. And so each order can have more than one row, but each individual item we sold is going to be identified by a single row. Our second file, menuitems.csv, is a table containing all the unique items we sell at our restaurant. So for example, item ID 101 is a hamburger, its category or cuisine type is American, and it's sold at a price of $12.95. So in order to get a sense for revenue by item or revenue across time, we're going to need information from here as well as our orders table. Let's go ahead and dive into the analysis in Python. To conduct this analysis, we're going to be using the Pandas library, which contains a ton of amazing analytical functions. So we're going to import pandas as PD, and then we're going to use pd.readcsv to read in the orders.csv file. This function returns a data frame, Pandas equivalent of a data table, and here we can see all the same data that we saw before, but Pandas also adds on an index, which adds on a unique row level identifier. In order to do much with this data frame, we need to store it in a variable. So I'm going to store this in the variable orders df. Storing it in a variable makes it easy to do things like call functions and methods on it. So if I wanted to inspect my data to make sure things looked correct, I could use the head method, which by default looks at the first 5 rows. So far, so good. If I wanted to peek at more data, I could look at head 10, which would give me the first 10 rows. And so we can see that the first order was placed on January 1st, 2023. And if I was curious about when the last order was placed, I could look at tail. Here we can see that the last order was placed on March 31st, 2023. So we have 3 months worth of data. It looks like it's been read incorrectly, but let's check the metadata of this data frame to confirm that. So I'm going to use the info method to take a look at the data types as well as missing values. So orders df.info. And here we can see that our data frame has 12,234 total entries. That means 12,234 total items were ordered during this period. We can take a look at the data types of each of our columns. So for example, order timestamp was read in as an object, which is not what we want. We want it to be read in as a date time so we can perform date time level analysis on it. But looking at our next few columns, we can see order details ID is an integer, that's numeric, order ID is an integer, and item ID is a float. Technically that could be an integer, but it's okay to leave it as so. but we do need to correct this data type issue. And we can do that within the read CSV function. So I'm going to do parse dates, and then I'm going to pass a list. I could pass in multiple date time columns if needed, but I'll do order timestamp. If I run this again, we can now see that our order timestamp column is stored as a datetime 64, which is exactly what we want. The other thing that the info method tells us is how many missing values we have. And what this actually tells us is non-null. It's a little counterintuitive, but if this number matches the number of total rows, that means we don't have any missing values. Where we do have missing values is item ID. We have 12,097 non-null values, which means we have about 130 missing values in this column. And we're going to need to drop those because we're not going to be able to join to our menu items ID table. So let's go ahead and clean up those missing values now. Because item ID is our join key with menu items, there's not really much we can do in terms of imputing this or any other handling. We're just going to simply have to drop any row that has a missing item ID. We won't be able to capture revenue or item level information, which means that these rows are going to be useless for our analysis. We should make a note to the manager to investigate why item ID is missing for some rows, because this could be an error made by our staff, this could be a systems issue, but ultimately for this analysis, the best thing that we can do is simply drop these rows. So if we do orders df.drop in A, this will drop any row with a missing value. And if we take a look at the output, again, this returns a data frame, and we can see this returns a data frame with 12,097 rows. So the next thing we need to do is store this. So we're going to overwrite our original data frame with the rows dropped. So we'll go from 12,234 rows down to 12,097 rows and move forward with orders df. Now let's go ahead and join our menu items table. So menu df is going to be equal to pd.read CSV menu items.csv. Then let's take a look at the head of this data frame. All right, and this looks like it was writing correctly. Once again, let's look at info to make sure all of our columns are correct. And first of all, we have no missing values, so that's good. We have an integer for menu item ID. Our item name is a text column. Category is a text or object column. And finally, price is a float. So it looks like we're good to go. We can go ahead and join our data now. So I'm going to create a new data frame, which is going to be the joined result. So order items df is going to be equal to our orders df.merge. This is going to perform the join for us. We're going to pass in the table we want to join, which is menu df. How do we want to do this? I'm going to perform a left join, but there are options for inner, right, outer. In our left table orders, our join key is called item ID. So I'm going to specify left on item ID. And in our right table, this is called menu item ID. So right on equals menu item ID. And let's go ahead and take a look at the head of this data frame. All right, so we successfully joined our table. One thing that we do have is a duplicate item ID. Because these had different names, our join pulled them both in. So let's go ahead and drop the duplicate. So drop menu item ID, axis equals 1 for columns. So now we have our data joined. We're just about ready to perform our analysis, but our managers asked us to report this in terms of total revenue, not just price, which means we need to add a sales tax to each of our line items in order to calculate the total top line revenue. So let's go ahead and define our sales tax column first. So I'm going to create a new column. The way we do this is specify our data frame. So order items df. We create a new column name. So I'm going to call this sales tax. And then we just assign a value. So I'm going to specify that this is equal to our order items df price column. And we're going to multiply price by 0.08 for a sales tax of 8%. Let's go ahead and take a look at the head of our data frame once we do this. Order items df.head. And we can see we have a sales tax column. For our first item, Korean beef bowl, our sales tax was $1.43.6. So we have 3 decimal places. That's not really going to work. We can't pay a fractional cent. So let's go ahead and round this. So I'm just going to wrap this in parentheses and then call the round method. And I'm going to pass in 2 to round to 2 decimal places. So if we run this again, we'll now see that our sales tax is 2 decimal places. Then we're going to calculate a total revenue column. So order items df total revenue is going to be equal to our price column plus our sales tax column. And so all we're doing here is using the addition operator to add price to sales tax to get a total revenue column. And so our total revenue, and this is what we'll be using for our analysis, is $19.39 for a Korean beef bowl. That's equal to the original price, $17.95 plus our sales tax, $1.44. And one very other helpful tool in Pandas is the describe method. So order items df.describe. And by default, this returns a table full of statistics for our numeric columns. There is an option to look at our categorical columns, but we'll just focus on our numeric ones. So our ID variables are not going to be very interesting, although you can use these to intuit the maximum ID, which often corresponds to the total number of unique values. So for example, there were 12,234 menu items, 5,370 unique orders, so a little bit more than 2 items per order. Looking at price, our lowest priced item, the minimum here, was $5. Our maximum priced item was $19.95. Our median price, our 50th percentile, was $13.95, but our mean is actually a little bit lower at $13.16. That means that there are a few really low-priced items dragging down our mean price, which is why it's lower than the median. In order to calculate the best-selling item, we're going to need to group or aggregate our data frame. We're going to group it by item name. We're going to do order items df.group by. We'll pass in the item name column. And there are a few ways to do this. I like the ag method. So I'm going to specify the column that I'm going to aggregate, so total revenue. And what type of aggregation do I want to perform? We want to look at the sum of revenue, so I'll pass in sum. If I run this cell, we end up with the table that has the sum of revenue for each item. So California roll, for example, sold $4,583. But looking at this data, it's not sorted, so it's very difficult to come up with any insights. So let's go ahead and sort our table. To do that, we use .sortValues. This is going to sort our data frame by the values in the specified column. In this case, we're going to pass in total revenue. Let's go ahead and do that now. And so here we have chicken tacos as our lowest selling item at $1,587. And our highest selling item was Korean beef bowl at $11,401.32. When our lines of code start to get this long, one thing I like to do is wrap my code in parentheses. This allows me to put line breaks wherever I want, so I can put each of our methods on a single row. And so it makes it very easy to scan, order items for grouping, aggregating, sorting. And while this table gives us the information we need, it's still hard to analyze. So let's go ahead and visualize this data using the plot method. So I'm going to do .plot. And then for a horizontal bar chart, I'm going to do .bar h. If I wanted a vertical bar chart, I just do .bar. But this returns a horizontal bar chart that shows that our Korean beef bowl is by far our best-selling item with about $11,000 in revenue. Our second place item is spaghetti and meatballs at about $9,000, and so on. But focusing on areas where our restaurant could improve, we see things like chicken tacos, pot stickers, chips and guacamole, hot dog, and cheese quesadilla, as well as veggie burger, all below the $3,000 in revenue mark. So if we were looking for an area to improve operational efficiency and maybe cut down on waste in terms of ingredients, this would be a good place to look. Something like chips and guacamole is an appetizer that would add to the order of other Mexican items potentially. But a main course like a hot dog and a veggie burger that aren't being ordered a lot probably means that we're wasting resources even having these on our menu. And if we wanted to hone in on a specific cuisine, we could filter this using query, so .query. And maybe you want to look at our Italian items for opportunities within each cuisine. We could do category equals Italian. And this would allow me just to focus on each cuisine one by one. And so here we can see our lowest selling Italian item was cheese lasagna with about maybe $3,500 in revenue. But regardless, I think we're best off cutting something like our hot dog, our cheese quesadilla, and veggie burger. Now let's move on to our time series based analysis. In terms of analyzing the busiest times, there's a few ways we could do this. The first simply being plotting a line chart of the busiest times, whether that's hour, date, month, across our data, which ranges from January 1st to March 31st. So we could do something like this. Order items df. And we're working with time series data in Python. If we set our index to be our date time column, that will allow us to do some really nice time series aggregations. So we'll do set index. We'll specify order timestamp. And so if we take a look, we can see now that our order timestamp is the index of our data frame. That sets us up the ability to do resampling. which is aggregating based on windows of time. So if I pass in day, this will perform daily resampling or aggregation. And from there, I can select the column of interest, total revenue, and calculate the sum for each day in my data set. Finally, I'm going to plot this. By default, the plot method returns a line chart. And so if I plot this, I now have the daily revenue for every day in my data set. And here, it's really hard to discern a given trend. We might consider looking at month. And while this looks extreme, it's actually quite small because our y-axis starts at 55,000. So if I specified ylim equals 0, we can see there really isn't a monthly trend, but there's a better way to analyze seasonality. In order to do that, we need to create two columns, one for the day of week and one for the hour of the day. So let's go ahead and do that now. Order items df, day of week, and this is going to be equal to our order items df order timestamp column dot dt that accesses the time parts, and we're going to do day of week. If we take a look at the head of our data frame, we can now see that we have this day of week column. In Python, 6 equals Sunday, 0 equals Monday. It can be a little bit confusing at first, but you'll get used to it. And then if we want to do hour, we just need to do order items df hour is going to be equal to, I'll just grab this same string here. So order items dt, but instead of day a week, I'll pass an hour. And so now we can see that hour here is 11, that's 11 a.m. This is on a 24-hour scale. Hour 0 is midnight, hour 23 is 11 p.m. But now we're ready to create a pivot table. So if you're coming from Excel, you're probably very familiar with these, but we're going to pivot our data so that our rows are the hour of the day and the columns are the day of week with the sum of revenue for each day of week hour combination. So what we're going to do is order items df.pivot table. And we're going to specify the rows or index of our data frame is going to be equal to our hour column. And the columns of our data frame are going to be equal to day of week. For the cells or the values within them, we're going to specify values equal total revenue. And the aggregation we want to perform, the ag func, is going to be equal to sum. And you'll see here that we have day of week ranging from 0 equals Monday to 6 equals Sunday as our columns. And our hour ranges from 10 a.m. to 11 p.m. But this is a little bit challenging to analyze, so we can import Seaborn, a data visualization library, to help us add color to this. So sns.heatmap. I'm going to wrap this entire block of code in parentheses. And if we run this cell now, we can start to see a little bit more patterns going on. I'm going to go ahead and annotate this just a little bit more. So I'm going to first indent this block of code. And then what I want to do is add annotation. So annote equals true. We'll add data labels. By default, Python will make this scientific notation, but if I do format equals G, this will now be a little bit nicer format. But let's go ahead and get rid of these decimal places. So I'm going to do .round, and if I don't pass an argument in, this will round to integers. And so now we have nice whole numbers. The last thing I'm going to do is change a color scheme with a color map, and I'm going to do VLAG, which just makes it a little bit more intuitive. So red cells are going to be our highest selling periods, and blue are going to be our lowest. And the first thing we notice is that there are a few anomalous sales that happen likely outside of normal business hours. So 10 a.m. we had 2 one-off transactions. Someone on site probably opened the door a little bit early, and we see something similar at 11 p.m. But the most important part of this analysis is that our lunch hour, 12 and 1 p.m., are by far our highest revenue drivers. And if we take a look at our evening hours, so 5 to 7 p.m., that's when we see a spike in sales again. Our single biggest hour is lunchtime on Sundays. But one thing that our heat map quickly highlights is that 10 p.m. is not very busy at all. We don't see very high revenue values. And it's likely that we're losing money during these hours because we're staffing a restaurant that isn't getting much revenue, especially compared to other hours. We could also make the argument that at hour 21 or 9 p.m., we might want to shut down on Sundays as well because our business falls off much faster than it does on other days. So between reducing our menu size as well as optimizing our hours based on this heat map, we can make some nice recommendations to the manager of this business. So there you have it. In under 20 minutes, we profiled our data, explored and aggregated it using functions like group by and pivot table, and built charts to help generate crystal clear insights. If you'd like to dive deeper and start building expert level Python skills, Make sure to check out our Python Specialist Learning Path at Maven Analytics. You can also explore our entire library of self-paced courses, guided projects, and portfolio tools, and create your own personalized learning plan for free. Thanks for watching, and make sure to like, comment, and subscribe for more content just like this. We'll see you in the next one.